Here is a real scenario. A team enables S3 versioning to protect against accidental deletion. Smart move. 2 years later, their 500 GB of active documents is actually consuming 5 TB of storage. Why? Every document revision, every save, every edit created a new version. Those old versions are still there, still consuming storage, still being backed up, still being replicated. Nobody configured what happens to old versions. S3 keeps them forever by default. That's one feature. Now imagine lifecycle policies, storage classes, replication strategies, all with architectural decisions that compounded over time. Today we are diving deep into S3 architecture, not just what feature exist, but when to use each, why it matters, and how they interact with production system. Storage classes, lifecycle automations, versioning strategies, replication patterns. Let's architect S3 properly. Hi, I'm Pratik Kumar Mohite, a cloud DevOps professional, and I built this channel for one reason, to help you think like a cloud native architect. Before we dive into storage classes and lifecycle policies, let's establish what S3 is and why it's foundational to AWS architecture. S3, which is also known as a simple storage service, is the object storage, not a file system, not a database, but the object storage. Every file you upload becomes an object with it has key, the file name or path, the value with actual data, example, the PDF itself, metadata, information about the object, content type, upload date, custom tags, version ID, if versioning is enabled. Object lives in buckets, containers that hold the unlimited objects with virtually unlimited storage. Why S3 exists? The 5 fundamentals. Durability, 11 nines. AWS replicates your data across multiple devices, multiple facilities within a region. Hardware fails, your data doesn't. Scalability, store one object or 100 billion objects. S3 scale automatically. No capacity planning, no storage limits. Availability, designed for 99.99% availability. Your data is accessible when applications needs it. Flexibility, multiple storage classes for different access pattern. Pay for what you need when you need it. Integration, works with every AWS service, Lambda triggers, CloudFront distribution, analytics with Athena, backup for databases. Let's see common S3 architectural pattern. Static website hosting, CloudFront plus S3. Application data storage, user uploads the media files. Backup and disaster recovery, automated snapshot. Data lakes, centralized analytics storage. Content distribution, global delivery via CDN. S3 is the foundation. Now let's architect it correctly. S3 has 8 storage classes, each optimized for different access patterns. The architectural decision, match storage classes to how you actually use your data. The storage class spectrum. Let's see first S3 standard, which is equals to frequent access. Access pattern, data access regularly, multiple times a month. The retrieval is instant, no retrieval fees. Durability is 11 nines across 3 availability zone, and the use case is active application data, frequently accessed file. The second one is S3 intelligent tiering, unknown or changing patterns. Access patterns are unpredictable. Data might be accessed frequently or not at all. How it works? Automatically move the objects between tiered based on the access. So if it is a frequent access, means less than 30 days. Infrequent access tier, 30 to 90 days with no access. Archive tiers is 90 to 180 plus days with no access. Use case is user uploaded content where you don't know what will be popular. S3 standard I, infrequent access. The access pattern is less than once a month but need instance access when requested. Minimum storage durability is 30 days. Retrieval is instant with per GB retrieval fee. Use case, backups or disaster recovery files. S3 one zone I. The access pattern are infrequent access, reproducible data. Durability 11 nines in single availability zone. Lower resiliency if availability zone fails. Trade-off is the lower cost for your data that you can recreate. Use cases are thumbnails, regenerated from original, secondary backup copies. The next one is S3 Glacier instant retrieval. Access patterns are archiving data needing milliseconds retrieval, rarely accessed but instance when needed. Minimum storage duration is 90 days, and the use cases are medical records or financial records. The next one is S3 Glacier flexible retrieval. Access patterns are archived data, or retrieval can wait minutes to hours, and the retrieval options are expedited 1 to 5 minutes, standard 3 to 5 hours, and the bulk will be 5 to 12 hours. Use case for the compliance archival or historical data. The next one is S3 Glacier deep dive. The access patterns are long-term archive. type. Retrieval can wait 12 to 48 hours. Minimum storage duration is 180 days, and the retrieval could take 12 hours standard or 48 hours for the bulk retrieval. Use case is 7 to 10 year regulatory retention. So ask yourself three questions. How often is the data access? Multiple times a month? Then you should go for standard. Don't know? Intelligent tiering. Within a month? Standard IA. Rarely or never? Go for Glacier. How quickly must a retrieval should happen? If you want a retrieval should be instant, go for standard IA or Glacier installed retrieval. If it can be minutes or hours, acceptable, go for Glacier flexible. Days acceptable, Glacier deep archive. Can this data be recreated if lost? No, you should go for multi-AZ classes, standard and standard IA. If yes, one zone IA is acceptable. Now let me show you how lifecycle automation works with S3 object. Lifecycle policies are how you automate S3 storage management. Set rules once and S3 execute them forever. What lifecycle policies do? There are two primary actions: transition and expire. The transition move objects to different storage classes. Expiration deletes the object automatically after specified time. Let's see one real world example. Application log archiving. So let's discuss about the scenario here. You have an application which writes the logs to S3 daily. The recent logs 0 to 30 days analyze frequently for debugging. The older logs 30 to 90 days access occasionally for investigation. Ancient logs 90 plus days kept for compliance rarely access. And logs older than 1 year should be deleted. Compliance allows it. So lifecycle policy would look something like this. Transition to standard IA for 30 days, transition to Glacier flexible after 90 days, and expiration 365 days. What happens? On the day 0, log file is uploaded to S3 standard. Day 30, automatically move to standard IA. Day 90, automatically move to Glacier flexible. On day 365, automatically deleted. No manual intervention, fully automated. The lifecycle policy architectural patterns. Start with the access pattern, not the storage class. So the wrong approach is, let's use standard IA to save money. And the right approach would be, we access the data monthly. So standard IA fits the pattern. Lifecycle policies apply to prefixes. You can target specific folders. Logs app for aggressive lifecycle, 30 days expiration. Logs for security, conservative lifecycle, 7 years of retention. Test expiration policy carefully. Deleting data is permanent. Use S3 object log for critical data that must never be deleted accidentally. The automation advantage. Manual storage management, someone has to remember to move or delete the files. Lifecycle policies you can set once and it runs automatically forever. This is infrastructure as code for storage management. Now let's see the versioning. Versioning protects against accidental deletions and overrides, but without strategy it creates storage challenges. So what exactly versioning does? When enabled, S3 keeps every version of every object. Upload document.pdf, it would have the version 1. If you update the same document and upload it again, it has version 2. But remember that version 1 will still exist. If you delete the document.pdf, a delete marker is added. Version 1 and version 2 will still exist. Why this matters? So if you accidentally deletes it, restore to the previous version. In terms of compliance, some regulations requires versioning history. Audit trail. See who modified what and when. So let's see the versioning challenges. Storage compounds. Users don't see the old version, but you are storing them. 500 GB of active files can lead to 5 TB of total with 2 years of versioning. The architecture solution lifecycle policy for non-current version. So S3 can distinguish between current version, the latest version of each object, and non-current version, all the previous versions of it. So lifecycle policy can target non-current versions separately. Let's see one real world example of document management system. Here is the scenario is you have a legal documents with versioning. Regulatory requirement. Current version must be instantly accessible. Recent history. 0 to 30 days occasionally needed for review. Older history 30 to 90 days kept for compliance and rarely access. And the ancient history is 90 plus days archive long term. So how the lifecycle policy would look like? The current version will have the S3 standard always. And for the non-current version, transition to standard IA after 30 days, transition to Glacier flexible after 90 days, and expiration 2 years or never if compliance required. Versioning architectural principle. So enable versioning for critical data only. Not all bucket need versioning. User uploaded media? Maybe not. Users can re-upload. Financial records? Absolutely. It has to have compliance. Application config? Yes. Rollback capability. Logs? No. no, append only and not updated. Always pair versioning with lifecycle. Versioning without lifecycle is the storage explosion. You could store more and more data without knowing about it. Data retention for non-current version from day one. Monitor version distribution. S3 inventory report can show you current versus non-current version count, storage consumed by the old versions, and candidate for the lifecycle optimization. Now let's see the replication. Replication copies object across buckets within one region or across the region. The architectural questions: when do you replicate and why? There are two types of replication: cross region replication. So example, the source bucket in one of the region US East 1 and destination bucket in another region EU West 1. Use case is for the disaster recovery, compliance, or global access. The next one is same region replication. Source and destinations are in the same region but different buckets. Use case are log aggregation, production test separation, account replication. Let's see one real world example: disaster recovery with cross-region replication. The scenario is critical business data is in US East 1. The requirement has to survive the complete region failure. The recovery time objective is less than 1 hour and recovery point objective is less than 15 minutes. The architecture has primary bucket company data US East 1 and the replica bucket is company data US West 2. Cross-region replication enables with replication time control, which is also called as the RTC. 99% of the object replicate within the 15 minutes. Replica delete markers disabled, so accidental delete don't replicate. Versioning required on both buckets. So how it works: application that you have will write to the primary bucket which is in the US East 1 region. S3 automatically replicate to US West 2 within the 15 minutes. If US East 1 fails, failover to US West 2. Maximum data loss could be the 15 minutes and we are achieving the RPO in this case. So let's see the replication architectural principle. Cross region replication for disaster recovery, not performance. If you need the performance, use CloudFront CDN, and we can talk this about in the next videos. Disaster recovery needs: use cross-region replication. Complete replica in another region. Replication requires versioning. Both source and destination bucket must have versioning enabled. This ensures all versioning replicates and maintain the complete history. Replicate selectively with filters. Don't replicate everything. A replicate prefix log production star, but not log test star. Replicate by tag. Object tag compliance true. Reduce replication cost and destination storage. Choose replication when you need true data redundancy across location. Let's bring it all together with a real production architecture that uses the storage classes, lifecycle, versioning, and replication. So the scenario here is the healthcare application with the compliance requirement. And the requirements are: patient medical images like X-rays, MRIs are uploaded daily. Images must be accessible instantly for 30 days for active treatment. Image access occasionally for 30 to 365 days for the follow-up consultation. Images archive 1+ year must be retrievable for audits. Compliance 7-year retention minimum. Disaster recovery must survive the region failure. Versioning track any modification for audit trail. The architecture: primary bucket which is in US East 1 has the storage lifecycle. 0 to 30 days go for S3 standard. 30 to 365 days go for S3 intelligent tiering. 1 to 7 years S3 Glacier flexible retrieval and 7+ year is the expiration allowed. Versioning should be enabled for the audit trail requirement. The non-current version can be transitioned to Glacier instant after 90 days. Retention 7 years for the compliance. Let's talk about the replication here. The destination bucket is in another region. Medical images DR US West 2. Cross region replication with replication time control of 15 minutes RPO. Replicate delete markers no, and replicate existing objects no, only new uploads. Why this architecture? In terms of performance, current images in standard for instance access. Cost optimization, intelligent tiering automatically optimize 30 to 365 days range. Compliance 7 years retention via Glacier. Versioning for audit trail. Disaster recovery is cross-region replication to US West 2 and we can achieve the RPO at 15 minutes. Audit capability versioning plus Glacier instant for previous versions. Architect's approach is start with the requirement. See the access pattern which will lead to the storage class decision. Retention policies, lifecycle expiration rules, compliance with the versioning plus archive strategy, and the disaster recovery for replication configuration. Then combine features to meet all requirement efficiently. This is production grade S3 architecture. Here is what now you understand as an architect. S3 is the object storage with 11 nines durability, unlimited scalability, and flexible storage classes. The foundation of modern cloud architecture. The storage classes which has 8 classes for the standard to deep archive. Match class to access pattern. If it is frequent access, go for standard. Unknown patterns should go for the intelligent tiering. Infrequent access, standard IA or one zone IA would be sufficient. Archive, go for Glacier, which has the instant, flexible or deep archive options. Lifecycle policy, automate transition and expiration. Set the rule once and S3 execute them forever. If these are logs, standard to IA to Glacier and then delete. If these are backups, start with standard, then Glacier instant and then delete. If it is media, different policies for originals versus the thumbnails. Versioning, protect against accidental deletion, but requires lifecycle strategy for non-current version. Always pair with the lifecycle policies, archive old versions to Glacier, monitoring version distribution. And last one is the replication. So cross-region replication for disaster recovery across the region and same region replication for log aggregation within the region. Not for performance, require versioning on both buckets and eventually consistent. The architecture's checklist for S3 is the access pattern. What storage class matches usage? Lifecycle. Are old objects being transitioned or deleted automatically? Versioning. Do I need it? If yes, lifecycle for non-current versioning should be configured. Replication. Do I need disaster recovery with CRR or just performance? Then use CloudFront. Monitoring. Am I tracking the storage distribution and optimizing? Next video, we will see the AWS IAM deep dive, policies, roles, and the principle of least privileges. We are covering the security foundation that controls access to everything we have built. What's your S3 question? Storage classes, lifecycle policy, versioning strategy, disaster recovery? Drop it in comments. Subscribe to Cloud Native Labs for production focused deep dives every week. Now go architect S3 properly. See you in the next one. Happy learning.